Hi, so in this video, I'm going to be talking about some part of nuclear chemistry that is half-life. So basically, there are two important formulas that can help you solve any type of like most of like not any type, but most of the half-life questions. So the most important one is this AF equals A naught equals negative KT, right? So A final means the final quantity, and A naught means the initial quantity, right? K is the decay constant, and T is the time passed. Okay, now let me explain the scenario. So on this planet, there are some radioactive material, right? Basically what happens is like if you put them somewhere after a period of time, they're going to decay, right? They're going to break down into different components, right? So that means like the initial one is going to be greater than the final one, because the initial one is going to be bigger and it's going to break down to form the final ones, right? And half-life is the time period it requires to get something to have its amount, right? Suppose if I have this rock or whatever, right? So the time period by which it looks something like this, right? It seems not like this. I mean, we just need one half. So roughly this one is uh is a half of this one, right? So this is the half-life, the time required to get something to half the amount, to half of its initial amount, right? Okay, now so again, this is the final amount, this is the initial amount, this is the exponential, and this is k is what decay constant, and then this is the time period. Okay, now a final, a initial, the time period, these are all experimental stuff, right? You find them through the experiments, right? But the decay constant is basically linked to something else. You derive the decay constant from this formula. K is the decay constant, and then you do ln of 2 by t half, or the time required to move to decrease and anything to have the radioactive thing, right? And ln of 2 is a fixed value, so we could write this whole thing, this whole equation as 0.6931 divided by t half, right? Okay, now we got two basic formulas. Perfect, let me move them to the one side. uh, okay, so now we got the formula. Let's try a question. So suppose um the final amount of iodine okay, actually iodine 131 has a half-life half-life of 8 days, right? And initial amount was 200 grams. And then we want to know how much will remain after 32 days. Okay. So let's try our first form, the main formula. AF equals A naught E K T. Okay. So our question is, how much will remain after 32 days? So we want to know A final. And then do we have the A naught or the initial amount? Yes, we do that. That is 200, right? Do we have the time period? Yes, we have 8 days, right? Half-life. Sorry, not that's 32 days is time period, right? That's this time, right? 8 days is the T half, right? In this formula. So that means we're gonna have to find the K first. So let's find the K. So K equals 0.6931. What is the half? This this thing, right? The time required to move something, to get something to half its amount. So 0.6931 divided by 8. So K equals 0.6931 divided by 8, which is 0.0866. So this is our K value. Now let's try to plug the whole thing and find the final amount. So AF equals what's A naught? That's 200, and then times E, and then basically, and then what's K? 0.0866 times, what's the time period? That is 32 days. Okay, now I'm gonna clear this out so that I have some space to write. So let's see, what do we get? So 200 times exponential negative 0.866 times 30. So I get 12.52 grams, right? So this is your answer. This is your final amount. Now we can try one more question. So suppose sodium 24 has half-life, or I'll say T half, which is the half-life, 15 hours. And then A naught is 800 grams, and A final is 750 grams. Right? Okay. Now let's write our formula. A final equals A naught KT. Okay, notice the change. Sorry. Notice the change here. So now we have the A final, A initial. We can find the K because we have the half-life, but we don't have T. So this time we'll have to solve for T. So let's solve for K first. So K is, gonna be ln of 2 divided by the half-life, which is 15 hours. So we get K as 2 divided by 15. 0.0463. Okay. Oops, here it's 0.0463. Basically, it's 0.0462. Okay, perfect. Now let's try to plug in and find the T. So A final is 750, A initial is 800, and negative of is 0.0462 times T. Okay, now let's get this 800 here. So it's gonna be 750 divided by 800 equals 0.0462 t. So get 0.9375. So basically in calculus, how you solve this equation. Uh, so how you solve this equation is you take the natural log on both sides to cancel the e. So ln of 0.9375 and then equals ln of e 0.0462. So ln cancels the e out, right? So this comes down. So it should be the natural log of 0.9375 is negative 0.065 equals negative 0.0462 times t. So we're gonna end up with negative 0.06. I'm just gonna do it here. Negative 0.065 divided by negative 0.0462 equals t. So we get, so negative negative cancels and we get 0.065 divided by 0.0462. So the time period that we get is 1.41 hours. So hopefully this makes sense to you. And if you have any questions, you can always ask me. And thank you so much for listening.